Alright students, in this video we are looking at the Pythagorean theorem and its converse. And this theorem applies to a right triangle. And as you guys know, we have three sides. We have the leg, this is one leg, another leg here, and this is the hypotenuse. And so what this says here is this: if I have one leg, and if I construct a square on that leg and add it to the square that is constructed on the other leg, then that sum will equal to the square built on the hypotenuse on this side. Thus we have a squared plus b squared is equal to this square called c. And that's where we derive that formula. A squared plus b squared is equal to c squared. Alright, so that's basically how this formula is derived. And with that, we can basically find the missing measure of any side as long as we have at least two sides. And later on in the chapter, when we get to trig, we'll be able to find measures with only one given measure. So in this case, let's look at one example. Let's say that one of these legs is 7 and the other leg is 17. Well, in this case we have a squared, so 7 squared plus 17 squared is equal to c squared. So we got 7 squared is 49 plus 17 squared is 289 equals c squared. And we know that c squared, we can isolate this c by taking the root of both sides. And so we know that 49 plus 89, or I'm sorry, 289 plus 49 is 338. And that comes out to be approximately about, I would say, 13, I'm doing this in my head, 13 root 2. And that's in simplest radical form. That would be the length of this hypotenuse here. And we can kind of play with this. If I was given C, and I was looking for A, then I would just substitute what I have into the formula here. So something like this. If I was looking for the other side, I would be able to find the value of A. Alright, so I think most of you guys have been exposed to this in the last chapter. So the next part we need to look at is something called the Pythagorean triple. And a Pythagorean triple, let me write down the actual definition here. The Pythagorean triple, let me just bring it over from another screen here. Copy and paste. Alright, we have it here. So a Pythagorean triple is basically a set of 3 non-zero whole numbers, such as a, b, c, where a squared plus b squared is equal to c squared. Let me show you what this means. Again, this applies to a right triangle. And basically what this means is that if I have a, b, c, all of these values have to be whole numbers. So for example, if I have 3, if I have 4 and 5, 3 squared plus 4 squared has to equal to 5 squared. Now all of these are whole numbers, so we get 9 plus 16 is equal to 25, and we know that's true. All right, so sometimes you might get a decimal, and that's okay, but that would not be considered a Pythagorean triple. To be considered a Pythagorean triple, all the numbers have to be whole numbers. So let me give you an example of other Pythagorean triple examples. So these over here will be Pythagorean triples. So there's actually quite a bit of them. And this is only a few of them up to the number 100. So obviously we have the first one, 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared. All of these would be examples of Pythagorean triples. So you may get a couple questions where you have to look at this. All right, so the next thing, and this is the final thing, we need to look at what is the Pythagorean converse. So basically what that is this. If we have a triangle and we have let's say A, B, and C. What this says is this: if we take the sides of A, square that, plus B squared, and if we get something equal to C squared, that would imply that this angle, and thus the triangle, is a right triangle. So working backwards in a way. So if we have A squared plus B squared, and that's equal to C squared, and that means that this must be a right triangle. All right, the next thing is what we call the Pythagorean theorem inequality. And so this says it's the same thing. It's referring to a triangle, So if I have a triangle and it looks something like, we don't know what it looks like quite yet, we just know that we have A, B, and C. This says if the square of the longest side of this triangle is greater than the sum of the square of the two shorter sides, then we know this is going to be an obtuse triangle. So if I have A squared plus B squared, and that's less than C squared, like this, we know that this triangle must be an obtuse triangle. Okay? Let me just, if you need to pause this, go ahead and do so. And let's look at the next part of this Pythagorean theorem inequality. All right, so the next part is this. Well, what if we have a triangle where, let's say it's something like this. Let's say I have A squared, B squared, and C squared. So let's say I have A squared plus B squared, and it's actually more than C squared. So that's what this says. If the square of the longest side is less than the sum of the squares of two shorter sides, like this, then we have this triangle here is what we call an acute triangle. All right. So again, if it's equal like that, if it's equal, we know it's going to be a right triangle, And if it's more, if this is more than that longest side, it's acute. But we know that if it's less, a squared plus b squared is less than c squared, then we know it's going to be obtuse. All right, I hope this makes sense. Please let me know if you have any questions. We'll see you soon.